The Great Red Spot is a persistent high-pressure region in the atmosphere of Jupiter, producing an anticyclonic storm that is the largest in the solar system. Located 22 degrees south of Jupiter's equator, it produces wind speeds up to 432 kilometers per hour. Observations from 1665 to 1713 are believed to be of the same storm. If this is correct, it has existed for at least 357 years. It was next observed in September 1831, with 60 recorded observations between then and 1878, when continuous observations began. Jupiter's Great Red Spot rotates counterclockwise, with a period of about 6 Earth days or 14 Jovian days. Measuring 16,350 kilometers in width as of April 3, 2017, Jupiter's Great Red Spot is 1.3 times the diameter of Earth. The cloud tops of this storm are about 8 kilometers above the surrounding cloud tops. Infrared data has long indicated that the Great Red Spot is colder than most of the other clouds on the planet. The upper atmosphere above the storm, however, has substantially higher temperatures than the rest of the planet. Acoustic waves rising from the turbulence of the storm below have been proposed as an explanation for the heating of this region. Careful tracking of atmospheric features revealed the Great Red Spot's counterclockwise circulation as far back as 1966, observations dramatically confirmed by the first time-lapse movies from the Voyager flybys. The spot is confined by a modest eastward jet stream to its south and a very strong westward one to its north. Though winds around the edge of the spot peak at about 432 km per hour, currents inside it seem stagnant, with little inflow or outflow. The rotation period of the spot has decreased with time, perhaps as a direct result of its steady reduction in size. The Great Red Spot's latitude has been stable for the duration of good observational records, typically varying by about a degree. Its longitude, however, is subject to constant variation, including a 90-day longitudinal oscillation with an amplitude of ~1 degree. Because Jupiter does not rotate uniformly at all latitudes, astronomers have defined 3 different systems for defining the longitude. System 2 is used for latitudes of more than 10 degrees and was originally based on the average rotational period of the Great Red Spot of 9 hours 55 minutes 42 seconds. Despite this, however, the spot has lapped the planet in System 2 at least 10 times since the early 19th century. Its drift rate has changed dramatically over the years and has been linked to the brightness of the south equatorial belt and the presence or absence of a south tropical disturbance.